Hello and welcome everybody. Thank you for joining us today. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speakers for today. Mike Gualtieri is Vice President and Principal Analyst for Forrester Research, where he covers artificial intelligence and related data technologies. And Ingrid Burton is a business leader from H2O.ai, and they're going to be talking about the 7 key elements of an enterprise AI strategy. Before I hand it over to Mike and Ingrid, I'd like to go over a few webinar logistics. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. This webinar is being recorded, and a copy of the webinar and slides will be available after the presentation is over. Now, without further ado, I'd like to hand it over to Ingrid.
Hey, thank you, Patrick, and thank you, everyone, for joining us today. We're very excited about this topic, and very excited to have Mike Gualtieri from Forrester Research here. He's an expert, I believe, in this topic. But before we begin, and I hand it over to Mike, I just want to say a few words about H2O.ai. For those of you that don't know us very well, we are the open source leader in AI and machine learning. We have both the open source and commercial versions of the product used by over 18,000 organizations around the world and by hundreds of thousands of data scientists on a daily basis. So we have a huge following on the data science community, and we are seeing what's now happening with AI and machine learning and how people are looking at it in terms of making a difference in their company or in their business, and looking at it from the standpoint of how do they get a competitive advantage or a competitive edge. So we're seeing that around the world right now, and I thought what we would do is have Mike talk about what are the 7 key elements that you need to think about as you embark upon an AI strategy or an AI journey. And so with that, I'd like to hand it over to Mike, who's going to give you a number of insights because he talks to a lot of clients out there as well. So Mike, thank you for joining us.
Thank you, Ingrid, and welcome everyone. My name is Mike Gualtieri, Principal Analyst at Forrester, and I cover AI and data-related technologies. And as we get going here, the first thing I want to do is sort of level set, right? Because what we're concerned with here is enterprise AI, and what does that actually mean, and what are the use cases? Generally, there's a lot being said about AI. Apocalyptic visions and things like that. But our analysis is that we believe that AI, like many technologies, is actually going to have a net positive effect, not only on enterprises, but on society in general. There are certainly challenges, and part of our strategy elements will go over that. But it's enterprises that are actually going to use AI to make things like healthcare more effective, transportation safer, processes more efficient, more personalized customer experiences, and many, many more use cases. So that's you. That's you and your enterprise going to make that happen as well. Now, there's a couple of very high-level use cases because people talk about augmenting intelligence with AI, and certainly that is one of the use cases. AI technologies can be used to augment employee intelligence, make them smarter, make better decisions. That's certainly one use case, but it can also be used to automate intelligence to improve the efficiency of operations as well, and that is certainly a use case as well. And we're also seeing it being used to acquire environmental intelligence, competitive intelligence to detect richer signals from the environment. So that's more of a business intelligence focus. We're also seeing it being used to hyper-personalize customer experiences. I mean, this is how the internet giants operate every day. And we're also seeing it used to accelerate and create new products that are based upon artificial intelligence. So when we think of enterprise, those are the generic use cases. Now, what I'd like to do now is get into some of the strategy elements that we talked about. These are the 7 key elements of an enterprise AI strategy. So the first one is to set the right expectations. I mean, the expectations that you set with your executive leader, or if you are an executive leader, that you set with the board, you have to set the right expectations. Otherwise, you'll be set up for failure. People might expect too much, but you also don't want them to expect too little. Now, at Forrester, we express two types of AI, pure AI and pragmatic AI. And pure AI is the sci-fi stuff. That strives to imitate humans, our very generalized intelligence. And we're really not much closer to that. There's research out there that shows, well, maybe in 125 years we'll get there. Maybe in 50 years we'll have elements of it. But pure AI, like you see in sci-fi, that's not what we're talking about. Pragmatic AI is what's realistic. That's what we can do today. That's what companies are doing today. So if you think of, an iconic example, IBM Watson beat the human Jeopardy champions. Very narrow focus. I mean, doesn't seem narrow. Jeopardy seems like you need to know a lot of things, but it's one particular application. And humans, we are fantastic at filtering information and then drawing connections through those filtering process. Computers are great at analyzing an enormous amount of data to find those connections. So it's pragmatic AI that you want to express. So the strategy element is to make sure you're discussing AI in the terms of concrete technologies. So in our view, AI isn't one particular technology, but rather it's comprised of one or more building block technologies. And we say one or more very carefully because it doesn't have to be all of these things, right? So if you think of a self-driving car, well, that's robotics with deep learning and maybe some knowledge engineering. But front and center are the data technologies, AI that is data-driven, uses machine learning or deep learning. And so those are the key use cases that we think most companies are and should pursue in their strategy. And when you think about machine learning from a business standpoint, the way that translates to business value is the ability to make a prediction about something, to make some kind of a decision, or to identify context, right? So translating it down to the element of machine learning and making a prediction, making a decision in your business, augmenting intelligence, those other elements I said, that sets the right expectations. So should focus on pragmatic AI powered more specifically by machine learning. Ingrid?
Yeah, so Mike, I was going to say that's an excellent thing for us to be focused on, because I think a lot of people, just like you said, they think about, ooh, the scary part of AI. Actually, AI is for good, and machine learning is really getting to predictions, like you said. And the way I think about it when I talk to business leaders at various companies is you have a business problem you're trying to solve, and you're trying to predict an outcome. And so pragmatic AI is about predicting outcomes and results and doing it in a much smarter way with all the data we have. So excellent insight there and an excellent strategy to get started here.
Yeah, because I think the worst thing you can have in an enterprise strategy is to have is for people not to be on the same page, to be continuously arguing about what it is and what it isn't. And you're right, at its core, it translates down to making some probabilistic prediction, right? I mean, like if you think, like in people's real lives, like Google Ads, right? An ad gets served based upon a predictive model, or a Netflix recommendation based upon a whole number of signals and factors in those models, or a customer that's churning. So ultimately, getting people on the same page and understanding what it is. Realistically understand it, because you don't want someone thinking, you're going to build, some sentient, intelligent robot that's going to become the CEO of the company. We're not there yet.
Now, we're far, far from that, and I always tell people that we're far, far from the Terminator world, very far away from that world, in fact, and we're really just trying to tackle, big problems that businesses are looking at, customer churn, or if you're in healthcare, what's a better outcome for a patient with predictive medicine and so forth. I mean, in insurance, it's better driving insurance based on your driving patterns and predicting what those will be. So, I kind of characterize this as, from algorithms to answers or problems to predictions.
Yep, I think that's a great characteristic and an excellent segue into our next strategy element, which is about the use cases. So the second element, and the key word here, if I were to underline bold, is the word multiple. So, it's tempting when you're using any new technology to just decide and prioritize one particular project to do a proof of concept. And it's not a terrible idea to do that, but you have to put that in perspective. You need to choose multiple, obviously they should have a high ROI use cases. And the reason for that is that machine learning is, for it to work, it's very dependent upon great rich data. And you may not have all of the rich data you need for a number of use cases. So enterprises who are successful, they'll pick not just one use case, but they'll pick multiple use cases, and they'll run those in parallel. Because the thing about machine learning is you have to analyze the data with algorithms first to know if you actually have the signal in the data. Now, the good news is that there are tons of use cases. People always ask me, well, what are the use cases? How many business processes do you have? How many customer experiences do you have? Because in each and every one of those, there's probably a use case. There's probably multiple use cases. And it's not that hard, actually, to surface those use cases, especially if you bring this down to a prediction or a decision or an identification, right? Because if you whiteboard a process, a business process, and at each step you ask yourself a question, is there something I could predict there that would make this more important, more successful? Is there a prediction I could make that I could route this to a different business process? Is there a prediction I could make in this customer experience that could create a more personalized experience? It's easy. You'll come up with dozens of use cases. And we have a data point too. I mean, the good news here is that enterprise decision makers see that potential in machine learning. They see that it's applicable in both front and back office applications. So, like a few examples, and to demonstrate the scope of the possible use cases. Companies are using it to predict supply chain issues. Again, predict is a key word here, because if you can predict the likelihood that an issue is going to happen, you can probably do something about it to stop it. Companies are using it in IoT models to prevent operation shutdowns by predicting outages that are likely to happen, or even during storms, using machine learning models to position crews where, based upon weather models and the age of the infrastructure, to position those crews where they're likely to be needed the most. It's being used by airlines to customize the catering. This one airline reduced their cost by 12% by using machine learning models to predict what catering to put there based upon the passengers, based upon the locations and the destination. Of course, it's being used in e-commerce all the time. I mean, I would say that Amazon is a machine learning company, and if you look at Jeff Bezos' letter to the shareholders, there's not one letter that goes by where he doesn't talk about the importance of machine learning to hyper-personalized customer experiences. We're seeing it being used to personalize customer service, to allow self-service through the use of chatbots, but also to provide a very personalized experience, an example of augmenting an employee's intelligence so that they're better able to speak to existing clients. And it's also being used in store experiences to offer real-time targeted offers based upon who the person is, what their shopping history is, and other factors that are occurring that day. And when you go to the deep learning, which is a form of machine learning, it's being used in image detection, medical imaging, and it can diagnose disease, some diseases more accurately and faster than doctors. And we're also seeing insurance companies use it to automatically assess damage and repair costs. I could go on and on, but the important thing here is that there's many use cases in your enterprise, and what we've experienced when we talk to companies is that they're confused. They don't know where to start. But the way to know where to start is to look at your existing business processes, look at your existing customer experiences. Those use cases are there. Just be sure that you pick multiple use cases. It's a little bit like a venture capitalist. A venture capitalist does an analysis and they may invest in 12 companies. They know statistically that 3, 4, they're lucky half will be successful. And machine learning requires a similar investment. The implications this has for strategy is also how it's budgeted and how you proceed with the projects. Ingrid?
Yeah. So Mike, I think that's just excellent. And I think what I would add to all of that, what you just said in the very interesting use cases that you presented, generically, is that, first of all, machine learning and AI can be used extensively across every industry. So we see use cases in manufacturing, in banking, capital markets, insurance, healthcare, retail, telcos, you name it, you can find a use case. It's really as simple as, what business problem am I trying to solve where I need to predict a better outcome? What results am I trying to get? So back to try multiple projects is a great idea. Pick a few in one part of your business, whether it's in your sales and marketing forecasting. There's use cases right there. Supply chain optimization, and we're seeing at H2O.ai a number of companies in every single industry that are doing some amazing use cases and getting great results. So it's try a lot, I think is what you're saying, Mike. Try. Just sit down and work through some business problems, and you'll find out you have a lot of data that you've been gathering for years that you can now get real answers to.
Yeah, and doing multiple projects at once too. I mean, sometimes we talk about it as agile AI, right? Because when you think of an agile process, it's a very experimental process. But I sort of don't like the term fail fast, but it's sort of applicable, right? You want to understand if this use case is gonna pan out. The good news is in data science that happens very quickly, because the algorithms do that for you. You give it the data, but the algorithms do it for you. So you can find out and vet these use cases very, very quickly, and even quicker if you're using AutoML, which we'll talk about later.
Right. All right, cool. Let's keep going.
All right, so we just alluded to the fact that it's all about the data. So, in order, any part of a AI strategy, it's data driven. So it means that you're going to have access to all of that data. And that doesn't necessarily mean that it's some huge data project. It could just be permission to get data, right? We hear a lot that data scientists say, oh, I'm spending 60, 70% of my time getting the data. Well, you know what? When you start actually interviewing them and you asking them what's up with that, they'll say, well, I had to email someone to see what application this data exists in, and then someone else to get permission to use it. And, it becomes an email challenge versus an actual data acquisition challenge. So it's not necessarily a technical solution, although it helps that organizations have created data lakes. The good news is that organizations have so many applications. I mean, I talked to one financial services company. I said, hey, how many applications? What's in your portfolio? 3,000. Can you believe that? Well, that's because of acquisitions and things like that. But all of those applications could potentially generate the valuable data for these use cases. So that's the great news about enterprises. They have a lot of rich data. And if you look at some of the sources of data, the internet giants don't have this data. Enterprises have this data. And this is why enterprises are going to be successful with AI. And that's why they're going to make a difference in the world with this, it's because they have the data. But you have to provide access to it. And one of the reasons why we suggest the multiple use cases is because this is true. This is true for computer science, and it's true for data science, garbage in, garbage out. So if you don't have the right data, that use case might not pan out, or it might be hard to get that data. So you have to do multiple. Data infrastructure has to meet the requirements of machine learning. The algorithms, when they train a model, it's analyzing a lot of data, and you never do just one run. Very, very iterative. So the data infrastructure has to be in place to do that. The good news is that most enterprises have either a data lake, a data warehouse. There's a place where that data can gather, and then the machine learning platform they use can run that data. There's certainly cloud infrastructure as well that make it easy to be very elastic in this as well.
Yeah, so Mike, I was going to say, we've seen companies for the last, 5+ years going through a data or digital transformation and getting to a data-driven world. Now is the time for enterprises to take those data lakes, those data warehouses, and really provide actionable results, right? This is where they're going to be able to say, look, all that work I did to put that data lake together, or that cluster, what have you, or put it in the cloud, is now something I can use to predict a future outcome. And I think that's, it all begins with the data, and we now have ways to extract value from that data that are, up until a few years ago, were really hard to get.
And it's a happy coincidence that companies were creating data lakes primarily for like business intelligence applications. The happy coincidence is that same data can be used for machine learning as well. So, if we were going through a phase where companies were very interested in AI, but then they had to get their, think about data platforms that they would use, that would be adding another step.
Right.
But when we look at large enterprises, and I cover data-related technologies too, like Hadoop and Spark and other things. Most large enterprises, more than 70% of them, have done some sort of a data lake project.
Yeah, they've gone through that journey.
Ready to win, exactly.
Right, so they're ready. They're ready to go.
Yep.
Yep.
So, you've got your use cases. You understand that you need ready access to data and permission to use the data. Now you have to do the data science. Now you have to build the models. And one key strategy element is what are the tools that you use to do that? The data science teams or computer science teams, what tools are they going to use? And we think most companies can benefit from AutoML, and that's automated ML. A lot of companies and people in general are saying data scientists are expensive. They really aren't expensive. They're inefficient. That's because the tools that they're using, like I always say, if you look at data science teams, they're about 15 years behind where application development teams were in terms of tools, but that's now changing with AutoML. So what AutoML does is it automates key aspects of the machine learning model building lifecycle. And you can see the lifecycle here. It starts with data, it goes to data prep, feature engineering, and then a very iterative process of trying multiple algorithms and evaluating those models and putting them in production. This process hasn't changed much over the years. And a lot of the tools that data science teams use are straight programming, coding, whether it's in Python, R, Julia. And some of these steps can be automated. In fact, many data scientists, they do automate it. It's just they write their own code to automate it, right? And there was a big investment in that. But now what we have is a market with AutoML tools, which have started to create platforms that actually automate this itself. You can see here that at Forrester, we break down the market for machine learning tools into 3 segments. So one is multimodal, and that has to do with, it's got a wide breadth of tools like drag and drop, sometimes coding, some AutoML capabilities. Then there's the notebook-based tools that are code first. and then AutoML, which is specifically designed for the automation process. Now, we believe that a large enterprise probably has a need for each one of these approaches, and it's very akin to software development. Large enterprises, they do have .NET programs, they do have Java programs, despite certain tools that are out there, and that's because, okay, sometimes you need to code, but the lion's share of work can be automated or semi-automated. So, when you're looking at tools, we think AutoML has come of age. So what they do is they compress that time to model because they automate very time-consuming aspects of feature engineering, algorithm selection, and evaluation, in some cases deployment as well.
All right, so here's my commercial plug. So thank you, Mike.
You just happen to have an AutoML platform.
We have an AutoML platform, so it's called Driverless AI. It's not about autonomous driving, it's about self-driving AI, so automatic machine learning, just as Mike just said, that does it all in a single platform for data scientists, is going to do some of the heavy lifting, such as feature engineering that they've been doing, and also can provide some insights, interpretability, model, algorithm and model selection, training, which continues throughout the process, as you just saw, and also helps you not only interpret the results, visualize the results, and produce a scored model, which is called a pipeline. So you can deploy it across various applications and edge points as well. So just a little plug. We'll move off of this very quickly, but we'd love to have folks that are, if they're listening and they want to try it out, have the data scientists, data engineers, or even scientists and so forth, and business analysts could try this out for a 21-day free trial. It is really built for data scientists, by data scientists, and we'd love to have you give it a go.
Ingrid, one of the things I find fascinating, can you hear me?
Yes, I can.
Oh, one of the things I find fascinating about the AutoML too, and I alluded to this in my comments, that there were many data scientists who actually did do automation, but they coded it themselves. And what I find fascinating is how H2O has hired Kaggle grandmasters and got their insights about how to create an auto machine learning platform. Can you comment on that?
Yeah, exactly. Yeah, so exactly. Thank you. We have hired a number of Kaggle grandmasters, and there's about 100 Kaggle grandmasters. These are the experts in data scientists, expert data scientists that have earned that right through competitions, and so they've risen to the top. We have a number of them at the company, about 7 or 8 at this point, that are contributing to this product. So they're using all their tips and techniques to say, we know what you need to do when you've got this kind of data set, or you need this kind of algorithm, and they've injected that and put that into the product. So for those of you out there, you don't have to hire a Kaggle grandmaster. We have provided this platform gives you that tips and techniques that they have. And really, moving on is really to give you those same tools that the expert data scientists out there have. And I'll tell you, even expert data scientists can benefit from something like AutoML because it gives them results faster, so you can really focus on the next problem and the next problem that they're trying to solve. Because they are the whizzes at really solving business problems for you in your enterprise. And you want them to solve as many of these problems as possible. So democratizing data scientists is really important. It's giving everybody the same level playing field in terms of the tool sets. As Mike said, we need to get people caught up and get them into this new world of AI and machine learning so they can get the same results as the next guys or the next company over. Everybody that wants to be competitive moving forward is going to be using some form or fashion of AI and machine learning. Mike?
Yeah. Yep. And, just one more comment on this, and that is, basically how this works is that when you're trying to build a model, there are dozens, hundreds, and sometimes even thousands of choices to make. So choices on the features that you're going to use, the features you're going to create, the algorithms you're going to use, and how you're going to tune those algorithms. So there's potentially, dozens and hundreds, if not thousands of iterations. So why not configure the likely run and then just have the machine do it and then rank order the models based upon the evaluation method that you pick. So it's good stuff. And I think there's, a lot of exciting things happening in the tooling. I don't think it would have happened, though, if enterprises weren't so engaged and interested in AI. It sort of created the market for this, the demand.
Correct. Yeah.
So, and then, that brings us to our next strategy element, is to make sure that this isn't just about data science. And this really speaks to another challenge that we continually hear from data science teams. They've created the model they think is wonderful. It can predict, quality defects. It can predict a machine failure. It can predict what a customer will upsell, but then it's not deployed, or it's very, very difficult to deploy. And one of the reasons for that is that this a model that gets created impacts some business process. And if if you don't think about upfront how it's going to impact that business process, then you're going to have to do that work after the model has been built. And that could add potentially weeks or months to the process. The same is true with how an application is designed, the user experience. How is this actually going to surface in an application? So, in this world of AI, and especially in this world of machine learning, we often just focus on the model, and that's it. We're done. But a comprehensive AI strategy has to focus on how it will manifest itself in a business process and in those applications. So the strategy should prescribe the different teams that get brought in early on. So the data science team can go figure out if they can build the model, but the application, the design teams can figure out how that model will be used in those processes.
Yeah, I would totally agree with you, Mike, and that where we see success with customers that use H2O.ai is when they have the entire team involved. So AI as a team sport is super important. It's understanding that there's a business owner, there's probably a data engineer who may sit in IT, there's a data scientist, and there's kind of an end user customer as well that you're trying to serve. And so you have to think through not only the implications of using AI to streamline processes and so forth, or to solve business problems. There's a cultural thing here where people have to be on the, aware that these projects are underway and that it's giving them that extra intelligence and insights that they may not have had earlier, because data unearths so many different things for them, or the models do that. So we want to make sure that when we suggest this, we actually want to involve every stakeholder in an organization in order to be successful. Otherwise, if it's just a data scientist by him or herself, they've got a big uphill battle, maybe perhaps with their business leader who says, I don't believe that, I'm going with my gut feel. And we hear that sometimes. So we really have to bring them in early, bring them in as a cultural side of things, and make sure you think about all aspects of what business problem you're trying to solve and how AI will impact that.
Mm-hmm. Yep. Next strategy element is practice responsible AI. AI is fundamentally different from application code, or from code in general. It's probabilistic, it's data-driven, data led to the model, which makes the prediction. So it's fundamentally different. And AI solutions are a little bit like us. They are not perfect. They're probabilistic, right? So when you create a model to make a prediction, the reason why we say prediction is because it's probabilistic, right? And it may be 97% correct, or 98%, or maybe 87% correct, but they're probabilistic. So it's really important in an AI strategy to really lay out how AI is going to work and what the acceptable risks are. And first and foremost is be able to explain the models. And explainability is a big field of research, but there's also some pragmatic methods that are available in machine learning tools now and techniques. But business leaders rightly get nervous about agreeing to a black box that has millions of dollars worth of implications. So include a explanation in your strategy. And part of that has to do with auditability and recreating your work. I mean, explainability and recreating your work is absolutely essential, actually, in regulated environments, but it doesn't mean it's not important in non-regulated environments. It is. It is for the health of the organization. So you want processes and tools that can allow you to create the work. And this really means bringing a software development discipline to data science. I said earlier that, data science, the discipline of data science, is very much that of scientists. And they don't have necessarily all of the tools and the processes in place to recreate those models. So make sure that there's processes where you can absolutely recreate the work of a model, where someone leaves, someone comes in, you can absolutely recreate the work of that model.
Yeah, so responsible AI or explainable AI, really, if you understand that, first of all, in the regulatory environments like insurance and healthcare and financial services, there's regulations that are saying you have to describe your model, right? You have to reveal how you got these results. So there are technologies that allow you to do that. We do have that in driverless AI with machine learning and interpretability. But you have to guard as an organization against bias in your model. So that is true. You have to be able to explain the model. You need to be able to document it. You need to be able to, have some reason codes come out of your model. So therefore you can, quote unquote, trust your model, trust the AI. Mm-hmm. And it really is, just like any other business process, you must do some double checking to make sure that you're constantly guarding against things like bias, things like, outliers that can skew the results. So you constantly have to be on the guard for that. And it is all part of the AI journey that you're embarking upon or you're already in the middle of. And it is a key part of taking AI forward. Any other comments on that, Mike?
Well, I think the other big comment is that this is a very big topic because it also gets into ethical considerations of how models are used and things like that. So I've talked to very large enterprises that have a couple of people on their legal team, for example, looking into the ethics of AI and what that means for the company. So there's impact on a company's brand in terms of how they use it as well, but it's not that different. It's different, but it's not that different from any other technology that a company was going to use. I mean, this concept even came up with when mobile devices. Well, how do we use mobile responsibly? And AI is different, but it's not as different as people might think.
Well, it's not insurmountable, right? So
yeah, and here's one way to stay in charge.
Exactly.
And that's our next strategy element. Actually, you want to stay in charge, and what that means is mitigating the risks using human expertise to limit the risk of the model, and use the model to limit the risk of human decision makers. And so, our belief and what we've seen is that AI is smartest when it's driven by both humans and machines. So staying in control means you don't have to do what the model tells you to do. So the typical and easy to understand example I give is that, okay, you might have a model, and that model basically makes a loan decision. It predicts whether we should make the loan or not make the loan. Well, maybe an executive at the company says, I'm nervous. What if it decides to make $1 million loan? Guess what? You can just put program logic in that says if the model makes $1 million loan, don't do it. route it to a human. So it actually is quite easy to mitigate many of the risks or to govern edge cases that make business leaders nervous. And that technology is generally called knowledge engineering, but it's essentially rules where you can govern and even improve how a model works.
Right, I totally agree, Mike, that you have to have the human in the loop. I think regardless of the use case, every use case still needs human eyeballs and intelligence to help make it very successful. So it's really something that we constantly also advise is that, you know, back to the garbage in, garbage out, you need a human in the beginning and you need a human at the end, right? So you can guard against things going wrong, right? So they have to be constantly vigilant. And because we, as you said, even in your Jeopardy example, we make connections that a machine never can make, right? Like the $1 million loan example. A machine is going to just say, oh, yeah, this person's good for $1 million loan, maybe on a credit card, and we'd be like, that's crazy. You'd never do that, right? Mm-hmm. Maybe just a few people in the world could do that, but not a whole lot of us. So, I mean, there's stuff that, you know, you can guard against, but you've got to, again, it's a whole, as Mike said, it's a journey. It's this whole end-to-end process and kind of cyclical that you constantly need humans, you need teams of humans to be part of this whole experience.
Yeah, and Ingrid, it kind of gets back into the strategy element, make AI a team sport, because when you bring in the business stakeholders, the application development professionals, and the application designers, you know, you want to surface any concerns or challenges early, right? You don't want the data science teams to deliver a model, and now everyone's saying, oh, well, what about this? What about that? What about that? You'll add 6 months.
Right. You kind of need them in the loop. So we see this again as driverless AI, and we're going to get to questions here really quickly. Solves some of the key challenges that enterprises face today. So it's auto ML, as Mike said. It helps with the talent side of it. It's going to augment your data science efforts, and it's going to really amplify and accelerate them as well with a time element, saving you time, which results in ROI, of course. And then there's trust and being able to explain the model. So we're going to keep going.
So those are our strategy elements. We see AI as the fastest growing workload on the planet, and we say that from in all dimensions: infrastructure, development, applications. So we hope that those strategy elements will be helpful at your business. Thank you. I think now Ingrid will open it up for Q&A.
Yeah, we got a couple of questions that just came in over the course of this discussion. So I'll read them off. So this tool, I think they're referring to does it run multiple models at a time and suggest the best one, or does it only show the best at the end? Yes, it's all interactive, so you can pick algorithms throughout the process. You can there's a lot of dials for a data scientist to look at the algorithms. You can override what the tool is saying. It can suggest things, so it's iterative. The second question was, how do you classify natural language processing? Is this considered pragmatic AI, Mike, NLP?
Yes, it is. You know, natural language, I mean, it is what it says it is. It takes natural language, the way we speak. It also extends the way we write. And so that is definitely a part of pragmatic AI. I mean, there's all kinds of things to extract entities, topics, sentiment, all kinds of analysis that can be done. So definitely characterize that as pragmatic AI. Often it's done in combination with structured data. So you might actually analyze natural language to extract features from that text, which you will then use in a structured machine learning environment as well. And the other thing to consider here as well is computer vision. So, you know, when we put the technologies, we said machine learning and deep learning, you know, those are sort of the broadest possible categories, but there's computer vision with deep learning models and audio models. So NLP, we do consider that pragmatic AI. A pragmatic AI technology, I should say. Yeah.
Yeah, as a characterization of the whole category. Well, I think these 7, I think that's, we don't have any more questions that came in, and we're at 46 minutes or so. I think these 7 suggestions on embarking on an AI strategy for your enterprise are just top-notch. Mike, any final thoughts?
I would say that we, that right now we see more than half of the enterprises are implementing AI. And we just did sort of a projection of where we think that will be in the next 2 to 5 years, and we see that continuing to accelerate until about 3 years from now. We think more than 95% of enterprises will be reporting that they are implementing some form of AI. So this field is going to keep taking off, in our opinion.
Yeah, I would agree, and I think it's just a great time to be in data science, and really using that to better outcomes. So I think it's an excellent time to be looking at this new set of technologies that are out there and available to you. So I want to thank everyone for coming today, and if you're listening to the replay or you listen live, thank you again for attending our webinar, and thank you, Mike, so much for your interest.
Thanks,
your just great insights. Thank you so much.
Thank you. All right. Bye, everyone.
Bye.